So this is how we use science and scientific data. We try to predict, using our existing database, we try to predict what will happen in the future. Like if you have climatic change, like if you have your cycle, summer cycle, winter cycle for past 10 years, you will be able to predict, this weather forecast. They tell you today this will be your temperature, today that much will be the humidity. That is because of the previous records. So we start all that with observations. So that is what science is all about. So science, if you go in just small way, like you'll have a lot of fancy definitions that this is science is more about exploring, experimenting, trying to predict, modify, you know trying to control stuff. There are countries where they have this artificial rainfall. That is because we studied the rain cycle, we understood, and now we are using our knowledge to control natural phenomena. You can even control. So that, to that extent we have reached. So that is what science is all about. So to put this in very words, science is nothing but curiosity. Curiosity is science, and it comes from the Latin verb scientia, which means the process of knowing something. So we are basically trying to unravel the secrets of nature. So that is what science is all about. Now, when you go in the scientific field, you have these, there is a procedure to be followed, because as I mentioned, science is nothing but it is trying to understand things in a systematic manner. So this is the procedure that you got to follow. So you have first these observations, followed by controlled experimentations. Then you have this qualitative and quantitative reasoning, mathematical modeling. You will come up with some mathematical theories. Then you'll try to predict your conclusion part, and verification is nothing but when they try to validate your theory. So for example, if I want to study the sunspot cycle that is occurring on the surface of the sun, because sun is a heavenly body, it is a star where there is, it is not as calm as it looks. It is always buzzing with activities because of the change in its in the magnetic field of the surface of the sun. So if I want to understand the sunspot cycle, I will first start with observations. So I'll start noting down, okay, on this day I had these many sunspots, whether it was southern hemisphere or in the northern hemisphere. So I'll start noting down. I'll start taking my observations. Okay, these are these days I've got sunspots. Then you have controlled experimentations. For any process, you will have, you'll have the experimental part, you'll have the theoretical part, and you'll try to have that thing as close as, how much, like the more close your experimental and theoretical values are, the greater is the quality of your research work that you're trying to do. Coming to qualitative reasoning, so if I'm studying about the sunspots, we will try to understand how the sunspots are growing, whether it is enlarging, whether it is becoming bigger or it is becoming smaller, or there are regions like umbral and penumbral regions. So those are the regions with higher magnetic field and lower magnetic field respectively. Those things growing, whether the growth of sunspots is larger in the northern hemisphere, in the southern hemisphere, with what rate it moves, whether it is more in the in the equatorial region. So that is your qualitative reasoning. And coming to quantitative reasoning, then you'll put it down in numbers. Okay, this much red eye, this much diameter, this much red eye of the penumbral region, this much red eye of the umbral region. So when you put down things in terms of numbers, that will be your that will be your quantitative reasoning. Then mathematical models. Now you will try to understand patterns. Okay, you'll plot your graph. Okay, these are the things that I can get. So I get a peak value over here, I get valley over here when I'm plotting the graph. You try to validate what you have seen with the existing mathematical tools that are there. And then you'll try to predict that, okay, yeah, for these 11 years, we had maximum of sunspots in this region, or this was the rate at which my sunspots were moving from one limb of the sun to the other limb. Limb in the sense from one edge of, that is from one extreme diameter, that point, to the other extreme. And then your theory will go for further how far it is correct or not. Yes. So now coming to all the other forms of sciences, we have physics, chemistry, bio. So coming to physics, if you put physics just in a single word, it is nothing but it comes from the Greek word physic, which means nature. So basically that you're going to study anything about nature that comes under physics. So as the formal definition goes, it is the study of basic laws of nature and their manifestation in different natural phenomena. So that is what physics is all about. Physics is just nature and science is just curiosity. Science is nothing but curiosity. Now coming to another thing, science is ever dynamic. There is no final theory in science. Every time there will be some or the other, either a theory might be it might be disproven by someone and you get a new theory, or we try to mostly develop the existing one with variations, with the newer variations in that. For example, earlier we knew, so how it evolves. Earlier we knew that it was told to us that Earth is flat, and for a long time we believed that. Then we had an explorer who went round the Earth and he said that no, it is spherical in shape. So from flat to spherical to then, Nicholas Copernicus, he gave us this heliocentric model of our solar system. So helio is nothing but sun, which means sun is the center. And Earth revolves around the sun in circular orbits. But then later on, it was proven that it is not circular, it is elliptical in nature. So this is how things are dynamic in science. Things get evolved over a period of time. It is not that something that is told to you today, it will always be existing, that is something final, full and final. Okay, that is not the case. Like the time when Newtonian mechanics was at its peak, Newton was one of the most celebrated scientists at that time. So people felt that, okay, whatever, like it was hard to disprove whatever Newton said. But today we know that we need extra stuff, and Newtonian mechanics cannot be applied to the objects at microscopic level. And also uh, he had told that the velocity of light in water is more, but actually velocity of light in water will be lesser as compared to when light is traveling in atmospheric air. That is because of the change in refractive index. So there is no final theory in science, and science always gets evolved. And there were these extra things, when we were transiting from Newtonian mechanics to quantum, there were things like photoelectric effect that was not being able to explain by the theories given by Newton. So we had to come to quantum mechanics, which deals with quantization of energy. Like everything is in discrete packets, everything is quantized. There is no in between values. There will be no continuous values when you're moving from, whenever there is energy transfer taking place. So photoelectric effect, one such phenomenon was not being explained by the existing theories of classical mechanics. So we had to shift. So always things will get added up, or it might have, your theory might have to get replaced by something else, or it will get added up to the existing theory that is already there. Then there are two fundamental principles that are being followed in the physics world, that is either the unification or the reduction. So in unification, we actually try to unify as many things as possible. We try to generalize things under one force or under one entity. And reduction is that place where you have things occurring at the larger scales, and we try to take inferences from there and try to apply that at the smaller scales. So one such example of unification is like, So gravity is one such law which will explain you the reason of apple falling on the surface of earth. That is because of the gravity. And again, moon revolving around our earth, or earth revolving around the sun, that is again because of gravity. So these are, now again, apple is not going in a circular path, but it is falling onto the surface of earth, whereas moon is revolving, but both are occurring due to the same force, that is gravitational force. So this is how we are trying to unify, we are trying to generalize things under one subheading. And then this is one thing, that is the fundamental forces of nature, that one we will be seeing in the later part of this segment. And then reduction. Coming to reduction, if you have a system of particles, it's like if you have a container where there are large number of molecules, if it is a system containing gas molecules, so quantities like the pressure, the volume, the temperature, if you have temperature constant and your pressure and volume are varying with an inverse proportional relation. So when you're studying these macro state, these things of the gas molecules, you will not be really interested in what each and every molecule is going through. So these are all bulk phenomena over the entire region. So this is how we will reduce down from macro states. So pressure, volume, and temperature, these are the macroscopic properties of an object. And using these, you can understand the position and momentum of the particles which are inside the system, which is the microstates. So this is how we in reduction we will try to reduce down from higher scales to the lower scales. Now there are pathways in physics. So the immediate broad classification is the macroscopic and then the microscopic physics. So in the macroscopic level, anything that is happening at the laboratory, terrestrial or astronomical scales, it is all got to do with the large scale stuff. That is your macroscopic stuff, like a pressure, a force, a deformation of your solids, everything. Your body, cars moving every day, your everyday thing that is happening all around you. That is macroscopic stuff. And the microscopic level, whatever is happening at the subatomic scales, at the molecular level, what is happening inside the nucleus, energy generation, through nuclear fission, fusion, all of that will come under microscopic physics. So macroscopic physics is again divided into 4 categories, that is mechanics, electrodynamics, optics, and thermodynamics. So as I already mentioned, mechanics will deal with the objects at the larger scale, their motion, the forces acting on an object, or if an object is getting deformed, how much it is getting deformed, its elasticity, plasticity. Then you have quantities like stress, strain. Now there is a small difference between pressure and stress. Pressure is nothing but force by area, but stress is nothing but the restoring force. So like when you stretch a spring, there will be a restoring force generated. So all these things, like all these bigger objects which you can see, that will come under mechanics. And the foundation of mechanics was laid by Newton, which is Newtonian mechanics. Of course, the pioneers were Aristotle and another scientist, but most of it at your high school level that you deal with is Newtonian mechanics. Then later on, there were additions to it, like Lagrangian, Hamiltonian mechanics. So this is all about mechanics. Now coming to electrodynamics. So whenever there is a charged particle, we know that if there is a charged particle, if it is moving, there will be magnetic field generated around that. So all the interactions between charged particles, studying of these charges, that will come under your electrodynamics. Then coming to optics. Optics is not only the study of light, mostly you feel that it is the study of light, but it is also the study of instruments that interact with light, like telescopes, your microscopes, even studying the instruments which study light, that also comes under optics. Now coming to thermodynamics, it is also it deals with the temperature changes within an object and how the energy is going to change, how the temperature is getting transferred from one object to another, and the interaction of the body with its surroundings. And as I said earlier, the photoelectric effect and black body radiation, those stuffs were not being explained by the macroscopic, that is the Newtonian mechanics and all. So those things, to rectify all of that, we came up with quantum theory. So these things, as it is written, so it deals with constitution and structure of matter and its interactions with electrons, photons, and other elementary particles. So here, from these slides onwards, I would like to explain some of the phenomena that we come across in our daily lives. So what is actually that is happening in these things? So let us see those, now. So terminal velocity is that velocity. I just want to tell that it happens in both fluids, both liquids and solids. So if you have an object, if you see this, the person in the parachute, initially when the object is falling, or when the guy is falling towards the earth, his velocity will increase, right? Because it is getting accelerated due to gravity. So as he gets accelerated towards the earth, there will also be frictional forces because of the air molecules on to him, right? So as he keeps moving, his acceleration moves, and because he is moving, his interactions with the molecules of the atmospheric air increase, which acts as a resistance to his motion. And as he keeps increasing, the resistive force increases. There will be one point where these forces will be like equal to each other, and after that your object will not be able to accelerate, and after that point the object goes with a uniform velocity. So the point, the place from where it gets this this constant velocity, and after that there will be no more acceleration into the body, that velocity, that constant velocity, is known as the terminal velocity. And this phenomenon is used in, this principle is used in the parachutes. So these, it is because of this thing you would have seen that when a parachute is, he's falling off, initially he goes with a greater speed, and the moment he's in the air, when he has opened his parachute, he starts falling with a constant speed after some time. This helps him to not get injured throughout his journey. Similarly, now there's a next thing that we often observe. So mirage, this is one phenomena which is kind of an optical illusion. When you go on highways, you see that water is all around, but the moment your car reaches there, you see that there is no water. So whether water is there or not. So this is because of this phenomenon known as mirage. If you see on a hot summer day, what happens is the molecules, they'll be like at a higher temperature at the bottom of the surface, because of the heat getting transferred from from your desert area at this place. And as you keep moving upwards, your density keeps decreasing, because here when the temperature is high, your molecules vibrate, they expand. So here uh, your your these layers are more rarer, and as you keep moving, these are less heated up, these are more denser. So when light is coming from the surface of, sorry, from sun, and when it goes towards this tree, it gets reflected from that place. Now when it is going from one denser medium to the other rarer medium, at that time light rays, they will bend away from the normal. So you see, it bent away from the normal. Now again, from this medium to this medium, when it is coming, now this medium is more rarer than this medium. So again, from this medium to this medium, it will bend even more. And there will be one point at which, there is one angle known as critical angle. When the light rays are incident at critical angle, the angle of refraction will be 90 degree. And when your angle of incidence is greater than the critical angle, the object, the ray of light will fall back inside the medium. So it is totally getting reflected into the medium. It will not fall, it will not refract, it will not go ahead. So when this ray of light goes to this girl's eyes, she can see the image of the object somewhere being created over here. So this is why we see images of objects which are actually somewhere in the air, but you see it down. So this is a kind of optical illusion that occurs in everyday life. Another interesting phenomenon, that is advanced sunrise and delayed sunset. So we actually see the sunrise almost 2 minutes before the actual sunrise. If you can see, this is the horizontal line, which is actually a tangent to the earth. Now, when the earth is over here, this medium is this is your vacuum. So here, this is a rarer medium, and here, this region where there is atmospheric air, this is your denser medium. So when light goes, when it falls from a rarer to a denser medium, it will bend towards the normal. So these are the normals that are drawn. So when it is entering into the person's eye, despite the object, the sun being over here, it will enter the person's eye, and when you trace back the image, we see that the object is over here. So actually the sun is below the horizon, but what you see in the early morning, you feel that it is, yeah, sun rose and it is above the horizon, but actually you are seeing the sun which has not even crossed your horizon. Similarly, when the sun is over here, when it is exactly above your head, that is the real time image. I mean, that is the real position of the sun. It will be, because there will be very less chance for the rays from sun to get refracted, and the moment, I'm sorry, and the same thing happens when the sun is about to set. So it would have actually gone below over here, but still you will be able to see the sun. And at the horizon, when you're trying to take images of the sun, they'll be bit squashed image. Like it'll be little bit compressed. It'll not be of the exact diameter. That is why astronomers who are so interested in photography, they don't like taking pictures at the horizon, even in the case of any astronomical event, because it will not give you the correct diameter, because the rays over here, they will bend at a different angle, and the rays over here will bend at a different angle. So that will give you a smaller image over here. If from here, if it is getting bent more, here it will bend some more, and then at this point the image will get shrunk, so you get a smaller diameter. Then you would have come across two words, namely center of mass and center of gravity. But then there is a difference, because center of mass is that place where the entire mass of an object is supposed to be concentrated. But center of gravity is that place where the entire weight of an object is supposed to be concentrated. So center of mass is that point on a surface. If I do any operation, it will be applied to the whole of the object. Like for example, this person is holding this bird at this point. So if he will move his hand, the whole of, I mean, the bird on its, it will not be that only the beak of the bird getting moved forward and other things being static at other place. So it is that point where the entire mass of an object is supposed to act. Now, center of gravity will change, and yeah, center of mass will not change for any object. It depends upon the distribution of mass inside. But center of gravity will change because the gravitational field, the strength of the gravitational field lines will differ from one place to the other. Now, if you're on the surface of the Earth, the gravitational field lines will have uniform spacing between them. But if you go at higher altitudes, the spacing will be different, and the strength of your gravitational field lines will be different. So the weight of your object will be changing, and because of that, your center of gravity will change, because at that time your weight will be having a different sort of distribution, which will lead to a change in the center of your gravity. So your whole body's balance, it might shift when you're going from one altitude to the other altitude. Now, in circular motion, you might feel that the object is moving around. Okay, are you all clear with what is displacement, velocity? Can I have inputs from them? Like what is displacement? What is distance?
You can type in the chat box, students. Yeah.
And can my displacement be zero when I have covered a lot of distance?
I think they're typing. Yeah. Subhangi, can you see the chat box or do you want me to read it?
No, I'm not able to see the chat box here.
Okay.
Read it out to her.
Okay. Rupa says, yeah, it can, I think, for the question that you asked. Suryansh, okay. Kavyarni, the shortest distance between 2 points is displacement.
Yes, very good. So, okay, good that I could have covered some distance, but my final displacement will be zero. So that will happen in the case when you go for walking or jogging and you're covering circular distances for longer duration of time and you're completely tired, but after a complete round your net displacement is zero because my final position and my initial position are coinciding with each other. Now similarly in circular motion, if you are covering equal distances in equal intervals of time, and so you might feel that you are not accelerating, right? But because your velocity is changing at every point, your object is accelerating. So what if you're covering equal distances in equal intervals of time? So an object, even if it is covering equal distances, if it is having uniform speed, but because velocity is a vector and it has direction, so even if you're covering equal distances in equal intervals of time, you are accelerating because for any vector quantity like acceleration, it should have both both magnitude and direction. So if any one of the quantity changes, your quantity has changed. Now weightlessness is one phenomenon that we actually feel the weight only when you are in contact with the ground, because only when you exert a force the earth will also exert a force on you, and it is that point of time when you are experiencing weight. And any object which is under free fall under gravity, of course it is because of the pull of the gravity that it is falling onto the surface of the earth, but the object is actually feeling weightlessness. So this is what you experience when you're going in lifts, of course not fully, but it is a controlled environment, so you little bit feel weightlessness when you're coming down. Now for example, so yeah, any astronaut, when they are in the International Space Station, actually gravity is working on them because the International Space Station is revolving around the earth because of the help of gravity only, right? So actually they are also experiencing gravity, but they are under free fall. That is why they feel weightlessness. It is not that gravity is not acting on them, it is acting on them, but it is they are under free fall. So at that time they'll not be experiencing they'll not experience that weight on their body. For example, if you have a spring and it is not attached to any surface, any rigid surface, and if you attach a ball onto that and if you throw it, there will be no elongation in the spring. So when objects are under free fall, there will be no force. I mean, they'll not be experiencing that weight, that m into g in their bodies. Now this one is, why do we have a different season cycle in the northern and southern hemisphere? So the reason for that is because of the tilt of the earth, because it is inclined at an angle of 23.5 degrees. So this June 22, that is the summer solstice in the northern hemisphere. That same region is the winter solstice in the southern hemisphere. The reason again, it is because of this tilt. Now if you can see, the sun rays will fall perpendicular on the in the regions around the equator, so which means it has the intensity of light over there will be more. And here when it goes to the northern or the southern pole, they'll be slanting, which means the weight, it is because of this reason, the intensity of the rays over there will be very less. And because of that, we always see lower temperatures in the northern and the southern poles. After the revolution, when it goes to the other extreme, when you come to here, when you come to this place, December 22, when this place, when we are experiencing winter solstice, in countries like Australia, they'll be having heavy summer over there because of the tilt. So here, the southern region will be experiencing more of parallel rays from sun, and we will not be experiencing the direct rays from the sun. We'll be experiencing the slanting rays. So this is why we have this, when the northern hemisphere is experiencing, winter, we experience summer, and vice versa. And equinox, it is that time when you have 12 hours day and 12 hours night. So that is the equal distribution of the intensity of sun rays. Yes. Now coming to momentum. So I hope you all will be familiar to this term momentum, which is nothing but mass into velocity. Now how this is used in firecrackers. Whenever you are about to launch your firecracker into the atmosphere, the firecrackers will have some chemical potential energy stored in them. And the moment they get into the atmosphere, one particle, suppose it is going in some direction here, now the other particle, to conserve the momentum, if they are of the same masses, to conserve the momentum, it has to go in the other, in the opposite direction. So at that time, when one particle is moving in one direction, the other particle will move exactly opposite to that. And similarly, all the particles will happen to go this way. One goes to one extreme and the other goes to the other extreme. So that is how you get the radial patterns through the firecrackers. The same thing, if you are throwing a ball or if you are trying to launch a rocket from the atmosphere, let us go to this case first. If you are throwing a ball, it is not that just the ball is going towards the earth also gets attracted towards the ball. And because this one has a greater mass, greater velocity with which it will fall, its mass will be small. So to compensate for that, here a large mass will move with a very small velocity, and that will be around, it will be just in something in -2 into 10 raised to -22 meters per second, which will be close to the diameter of a nucleus, which the earth would have moved by the time this object falls on the surface of the earth. And if you want to launch a rocket, the firecrackers, where you just have to launch that with a very high velocity. Now, because it has smaller mass and the earth has a greater mass, all of the greater mass over here gets translated over there in terms of greater velocity of the object that you're trying to launch. So these are the benefits, like these are the ways you can apply momentum and the Newton's third law of motion in real life. Now, orbital velocity is something, okay. So escape velocity is that velocity which is required by an object to escape from the gravitational field. And orbital velocity is that velocity which you will require to be or to sustain in that orbit, in a specific orbit. Now, these two, very interestingly, do not depend upon the mass of the object that you're trying to launch. So whether you have to launch yourself or if you have to launch the entire International Space Station, it will not depend on your mass, because here, if you see, when we equate the centripetal force with the gravitational force, we'll have this mv square by r, and here we'll have gm m by r square. So that small m, which is the velocity of this object and this object, the mass of this object over here in centripetal force and that small m over here, those will get cancelled, and you have this velocity, orbital velocity, depending only on the gravitational field strength of this object, the earth, the m1, that is the greater mass of earth, and small r, that is the distance. So that is why you see when astronauts, when they have to repair something in their spacecraft or something, and when they're connected with each other, they both move with the same velocity, which means the velocity of any object which has to be launched in an orbit does not depend on the mass of that object. Yes. So yes, what is reflection? What is refraction? Can I get inputs from their end?
Guys, you can respond in the chat box. Her question was, what is refraction and what is reflection?
Rupa says reflection is reflecting light.
And refraction, and why does refraction occur? What is refraction?
Oh, sorry, I did not know. Rupa, I'm sorry. Rupa's daughter, I'm sorry.
Okay. So
Reflection is bouncing back of light. Refraction is bending of light.
okay. Yes, good. So why does the light bend?
Anybody? Why does the light bend?
When it is moving from one medium to the other?
Veda, Shri, some of you can answer that, I guess.
Its speed changes when it moves from one medium to another. It depends on the optical density.
Yes, very good.
Okay.
Yes,
So
yes.
reflection is copy of King's product by water or mirror.
Yes. Yes, so reflection is nothing but bouncing back of light, and refraction is nothing but the bending of light when it travels from one medium to another. And it bends because the velocity of light changes from one medium to another. So it is because of this thing that if an object is immersed in water, you see that you feel that the image is broken, but actually it is not. And if if you throw a coin or something inside, you see when you see it from the outer surface, you see it at a greater height. Like its actual depth will be something else, and you see that we call apparent depth and the real depth. So that is all because of this refraction, mainly because the velocity of light changes from one medium to another. And reflection is yes, as it is told, it is bouncing back of light. And after that, we have, like, if you can connect with what I told in the starting phenomenon, mirage that I was talking about. So when your incident light is greater than an angle, which is the critical angle, all your light gets totally internally reflected. So at that time, so this phenomenon is used in the making of optical fibers, and this is the fastest medium of communication, and it is also the cheapest. So this phenomenon, and also your data does not get lost. So this is actually an image of an optical fiber which is used in toys. So it is something that you have seen. It is not something something so technical, and it is only in an industrial level or something. It is something that is always visible to us. Optical fiber. These are all optical fibers. Yes. Surface tension. So any molecule inside any liquid, it will have some free surface. I mean, the topmost layer, if your water is inside a container, the topmost layer of any molecule, sorry, any liquid, it will not be completely immersed inside. So it is not surrounded by any other molecule on the outer surface. And those molecules those molecules possess some extra energy, and that energy is their surface energy. So every material will try to have this minimum of this surface energy. So for that, most of the times you would have seen water molecules, they'll be water drops, they'll be in spherical shapes, because spherical shape is that shape for any given mass, it will have the least volume as compared to other shapes. So they try to reduce their surface energy. Now to remove a molecule from the interior of the water droplet will be more difficult than removing it from the external surface, because the external surface already has some additional energy, so you will have to provide lesser energy only. So this is about surface tension, and it is because of this phenomenon only that there are some insects or water striders that they are able to walk. If you take the surface the surface of their leg in contact with the air, so using a shadow technique, they try to understand the buoyant force that is acting on this spherical, the area of its leg, and also the water striders will change their angles, their body weight and the angle at which they are exerting force on the water molecules, so that they don't drown inside the water. So this is how you can see surface tension all around you. And yes, force. So what is force? Or can I get inputs from their end? What is force?
Can you guys type in what is force? Force is the ability to do work.
Okay, any other input?
Force is a thing that influences an object. Force is the power applied to execute a task. Force is an act of push or pull through which object moves.
Okay, so these are like how we understand force in the daily life situations. So force is nothing but it can bring an object from rest, an object at rest to motion, an object which was moving, we can accelerate it more, we can increase its velocity, we can stop a moving object, a force is capable of doing that. It can bring in change in the direction of its motion. Again, force can do that also. Force can also change the shape of an object. Like if you are doing clay modeling, like in this picture here, so your force can change the shape, size, configuration of an object. So these are the things that force can do. And if you come to the more technical definition, so rate of change of momentum is force. So how fast you can change your momentum with respect to time, that is force. Now coming to the fundamental forces in nature. So the first one is gravitational force. So this is the universal law of gravitation given to us by Newton. So this states that every object will be attracting every other object. So every object is actually capable of attracting every other object, which will be proportional to their masses, to the product of their masses. And it will be inversely proportional to the distances. So if you have greater distance between the particles, lesser will be the magnitude of your force. And if you have lesser force, lesser distance between them, you have greater force. So gravitation can do these things, like as I said, an apple falling on the earth, or you have satellites revolving around you, the formation of galaxies, galactic clusters. So gravitation is something that is occurring at larger scales also. This is about gravitation. Now coming to electromagnetic forces. So these are 10 raised to 36 times stronger than the gravitational force. Gravitational forces are the weakest of all the forces that I'll be discussing. So electromagnetic force, as I said, if a charge is at rest, there'll be no magnetic force. But the moment a charge is in motion, there will be magnetic forces, a magnetic field will be generated around that. So electricity and magnetism are two inseparable phenomena. And if you have to tell about the difference between gravitational and electromagnetic force, gravitational forces are only attractive in nature, but electromagnetic force, it can be both attractive as well as repulsive. And in electromagnetism, you have like positive charges, negative charges, but there is no such concept of negative mass when it comes to the gravitational forces that you would have studied, or you might be going to study that. And the range of electromagnetic forces are shorter than the gravitational forces. If you have if and this actually helps you in your everyday life. For example, if you're holding a book in your hand, you feel, I mean, the weight of the object, the weight of the book is acting in the downward direction. So it is because you applying a normal force in the upward direction, you're able to, hold on to the object. Now, why are you able to do that? It is because of the interaction of charges on the surface of your hand and on the surface of the book that you're holding. So if electromagnetic force was not there, then your hand would have, hit the ground very badly under the weight of the object that you were holding. So if electromagnetic forces were not there, even if you would have had a feather on your hand, and if imagine there are no electromagnetic force, even that would have severely injured you. So that is the strength of electromagnetic forces. Coming to strong nuclear forces, these are the strongest of all the forces. Now imagine, now protons inside a nucleus, they are both positive charges and they both are going to repel each other. So if they're two repelling objects, if you have to keep them combined together, you should have something really, really strong. So that is going to overcome the attractive forces between the protons. So the strong nuclear forces act between a nucleus, I mean, between the neutrons and the neutrons, between the protons and the neutrons, and between the protons and the protons. And these are the range of these forces are like 10 raised to minus 15 meters, because this is around the this will be around the diameter of the nucleus. So these have to be the strongest forces, because only then when the nuclear fission happens, you get a lot of energy, right? It is because of this, because of the strong nuclear forces. Now the weak nuclear forces. So these are the forces which you come across whenever there is a decay process happening inside the weak nuclear forces. And the strong nuclear forces are not to be confused with the attractive forces between the nucleus and the electron, because those will come under electrostatic forces. So strong nuclear forces have got to do with what is happening inside the nucleus. Similarly, when a weak nuclear force, I mean, that whenever a decay process happens, like when a neutron is being converted to a proton, you get an electron and antineutrino coming out. So that is because of the weak nuclear forces between these particles. Now, weak does not mean that they are weaker than the gravitational forces. As compared to the strong nuclear force, these forces are weaker. I mean, these are weaker than the strong nuclear forces. And similarly, when a proton is getting converted to a neutron, you get a neutrino. I mean, you get a positron, and a neutrino is getting ejected out. So to put it in just one slide, you have the strong force that binds the nucleus. Those are strong nuclear forces. And the weak nuclear forces during any decay process, when there is radioactive decay. And electromagnetic forces are the forces that bind the atoms together. The electromagnetic forces are also responsible for the mechanical stress, the uh, thermal changes that are happening. Even those things are being governed by the electromagnetic forces. And of course, the gravitational force, we also know that, I mean, the sun is holding, like how Earth is holding the moon in its orbit. The gravitational force of sun keeps the solar system intact. So there are always also unification being trying to happen. People are trying to do that, but gravitation has not been able to unify. We are trying to unify the four fundamental forces, but we have still not achieved that. And any other force that is coming, I mean, apart from these forces, those are all derived forces. For example, when you stretch a spring, at that time you have, of course, when your molecules are getting stretched and compressed, again there are charges coming into play. Then frictional force, those are all the derived forces, and only these four forces are the fundamental forces. So yeah, this is all about my session. If you have any queries, You can ask me.
Thank you, Subhangi, for the wonderful session. Kids, we are open to questions. Can you please post your question?
Yeah, please ask your questions in the chat box, or you can raise your hand so Kavya can unmute you for you to ask questions.
Subhangi, there's a question. Can you please explain why magnetism occurs in simple terms?
Like normal magnetism or?
Okay.
I think it's a typical a magnet, for example, a bar magnet. I think that's what they're asking, Shubhangi.
Okay.
Normal magnetism.
Okay, normal magnetism is because when you have these ferromagnetic materials, or when you have an object which is being if it is kept inside a magnetic field, we call it magnetized, because if that is brought into the vicinity of another magnet, it will get attracted, or it'll get attracted by a magnet. Like if it is a bar magnet, you have okay, if it is just magnetism in like extremely simple words, not really.
Yeah. So, who asked that question? Okay, Kavya, who asked?
Manavalan asked.
Manavalan, maybe I'll try. So you see, Subhangi was explaining about how when a charge moves, when a electron or a proton, for example, they move, they create magnetic fields also, right? That's what Subhangi was saying. So all the objects are made up of atoms, and every atom has electrons in their orbit, and the electrons also spin. Okay, they spin on. So a spinning electron also produces a magnetic field. Okay, so by default, all matter has magnetic fields in it because the charges are moving. The charges are continuously moving in an atom, so they generate magnetic fields. But most of the objects don't exhibit magnetism because all these motion of charges, the movement of charges are not aligned. Okay, they are all moving in random directions. Okay, so one object is moving to the right, another object is moving to the left, their magnetism is cancelled. Or one electron is spinning in clockwise, another electron spinning anti-clockwise, so their magnetism gets cancelled. But there are some objects where they are aligned. So these motion of objects, charges don't cancel each other. Okay, those materials you call ferromagnetic materials, and there are so many other types of materials also, paramagnetic, and you have diamagnetism. Okay, so this is at a very simple level to tell you the reason why magnetism exists is because the charges in an atom, they move, they generate magnetic field. So that is where the magnetism is coming from. I do not know if I can like simplify it any further, but that is to answer that. Kavya can read out other questions to them.
Yeah. So Suryansh is asking, can you explain the strong nuclear force again? The connection between neutrons and all.
Yeah, actually, if you see a proton and an electron, they attract each other, right? Because unlike charges, they attract each other, and like charges, they repel each other, right? So if when they repel each other, that means to keep them intact together, there should be some strong force which can avoid it from getting repelled and getting ejected out of the nucleus. So to keep that intact, there should be some force that keeps these two together, which is like a proton and a proton, which is positively charged, which should actually by logic it should repel each other, right? Proton one proton should be repelling another proton, right? But they don't repel. They are kept intact. So to avoid, I mean, to stop them from repelling and going farther and farther away, we should keep it intact. So to for it to be intact inside the nucleus, there should be some sort of force which is avoiding them from getting ejected out. So that force is strong nuclear force, and it is a force which is charge independent. It does not depend. It will act between proton and proton. It will also act because a nucleus also has neutrons inside that. So proton between a neutron and a proton also, and it will also have neutron and a neutron, so interacting together. So the strong nuclear force will keep all these intact inside a nucleus. It is because by logic both proton and proton should repel each other, right, because of the same charge, but it does not happen. That means to overcome their repulsion, we should have something very strong which is keeping them intact inside the nucleus. So that is strong nuclear force. Yeah, is that clear?
Yeah.
Yes, I think Shubhangi, that is clear, Shubhangi. Kavya can read out the other questions.
So Srivatsan has a question. If we are exerting gravitational force, then why aren't we attracting objects with less gravitational force?
Okay, so on the surface of the earth, yes, every object will exert a force of attraction on every other object. Now, because we all are on the surface of the earth, and earth itself is so massive, if you can see, it depends upon the mass of two objects. Now, because the earth is already very large, that we are all, it is directly proportional to the mass of two objects. Now the earth is so large as compared to our size, you know, we are like so negligible masses as compared to the mass of the earth. So we all are strongly under the influence of the gravitational force of earth. So if you are having your laptop in front of you, you are also attracting the laptop, and the laptop is also attracting you. But because of the strong force of earth, because of its large mass, its gravitational force is much stronger than the force between you and your laptop, or between the books kept near you or your phone kept near you. uh, it is because of their small masses. So those forces, the force that is being exerted by you on the body, on your laptop, and the force exerted by the laptop on you will be very small, very negligible. So that will not act there. It will only be the force of the gravitational force, I mean, of the earth. Now if you go into outer space, yes, you if you have, in case of binary stars, if when they both are of the equal masses, they revolve around each other. So of course every object in this universe will attract every other object, and it will follow this rule. So is it clear?
Yes, Subhangi. Thank you. The next question is, why only metals get attracted to magnets?
It is because of as Obliana said, there will be there are regions known as domains, okay, which will have their magnetic field will be pointing in one specific direction. So in case of ferromagnetic materials, all their net magnetic moment will be in a specific direction. So such materials will get attracted to the magnetic field. And whereas in the case of where you have this magnetic fields, where these the internal at very smaller level inside the material, all the when those magnetic moments, when they cancel out each other, there'll be no net magnetic moment generated in that object. So such objects will not get attracted towards the attracted when brought under the vicinity of a magnetic field. So is this clear?
Yes, Subhangi, sir, I was muted and I was talking. Kavi, you can please read out the next questions. Yes, I have no internet connectivity. Is Kavya there? Hello.
Sorry, I was also muted and I was talking. I'm so sorry.
Okay.
Okay. Subhangi, I'm sorry. So the next question is how we came to know that neutrons exist.
That is for that. I think Chadwick was the person who told that who discovered neutrons. So I think he performed some experiment. So I'm sorry, I'll have to look into that exact experiment which Chadwick did for the discovery of neutrons. So
Yeah, I think he was performing an experiment on some radioactive elements like not radioactive, like beryllium and polonium, where he was trying to understand. So basically, when Chadwick was trying to understand or discover, understand the atomic nucleus more, protons and electrons were already discovered. So protons and electrons were already discovered by two different people, and they were trying to, I think they had some discrepancy in explaining mass numbers of the elements. Like, for example, helium had mass number 4 and atomic number 2, which means 2 protons. So they knew there was something has to be in addition to protons in the nucleus. They didn't know what it was. They were just hypothesizing, and I think in Chadwick tried to probe the nucleus a little more to understand if something more is there inside apart from protons, because there were some things that could not be explained, some kind of radiations that came out of it. It has to do with alpha, beta, gamma. Those of you who are aware of it, alpha, beta, gamma radiation. So they were trying to study the exact details. Like Subhangi said, I'm also not aware, but I guess this was something where Chadwick was trying to work on, and based on his experimental results and trying to explain a few aspects of his results, he came to understand the discovery of neutrons as a particle. It was the last particle within the atom to be discovered. First electrons, then you had protons, and then you had neutrons. The line of order of discovery. I think that's all I know. Also, Subhangi, yes, that's, I think, yeah. Kavya, you can read out the next questions.
yeah, thank you so much.
Yeah.
Thank you, both of you. So I think the next question is, will magnetic force react on vacuum space?
Yes, this electromagnetic forces, electromagnetic forces and gravitational forces, they do not need a material medium for their propagation. So though they will be exerting forces even when there is vacuum, when there is no other medium there. Yeah, gravitational and electromagnetic forces, they don't need material medium for propagation.
Kids, are there any more questions? If there are, we'll take a few more questions. If there are no questions, we will wind up the session. Okay, Akshay.
Yeah, we have, we'll wait for another 30 seconds to see if you ask questions. There is one more question. Was it answered? When will we attract small objects in space? That was answered, right? Srivarshan has asked, then will we attract small objects in space?
Yes, if you go inside, away from the gravitational field of any other massive object, like you completely come out of the gravitational field and no other field is acting on you, and if you have a small object around you, you will have some sort of attraction with that object.
Thank you, Shubhangi. I think that answered his question. Any more questions you guys got? Okay, how was the session? Did you learn something out of this session? It was interesting to me. I enjoyed it. Did you guys? So there are no questions. Yes, we have. Okay, Shubhangi, we are getting messages that they enjoyed the session and they learned a lot, and also